Welcome to the 23 Code Street podcast. We're here to make technology more accessible to everyone. If it's going to define our future, shouldn't we all be part of the conversation? I'm Serena.
And I'm Anisah.
So we're recording episode 2.
Yeah!
Yay! So let's start by talking about what we've learned since episode 1. Do you want to go first, Anisah?
Yeah, go on then. I'll go first this time. So I realised that I had competition after Serena's amazing fact from episode 1, but I'm still really boring. So I've been reading Naomi Klein's book, which is Capital versus the Climate. I'm really interested in that stuff. But one of the things that she talks about is how oil and gas companies lobby the government to block climate policies, which is just nuts. And also in the US, how oil and gas companies support and pay for candidates' campaigns so that they don't stand against them. So I was like, okay, well, the book's a little bit old. What are the current stats? And obviously, The Guardian's been doing this whole series on climate change. And I also wanted to find out a bit more localized info. So basically, fossil fuels' biggest 5 companies have spent 251 million euros since 2010 lobbying the European Union. So basically what this means is every time a new policy comes up to kind of support climate change and to kind of change the way we operate, they come in and try and stop it. And with so much money, it's just like, okay, well, this stuff is never going to get through. And so obviously the US 2020 elections are coming up, and this has been a really big contentious point. And lots of the front runners are now signing pledges saying they won't take oil and gas money. But some of the top 4 haven't signed this pledge. So it's like, well, if they're some of the most promising people to be the next president of the United States, are we again going to have the same problem? Which is really fascinating. Not a really happy fact, I know, but...
It is a very interesting fact, especially with the campaigning, as, yeah, there's basically powerful people making other powerful people be in power.
Yeah, and I think with all this stuff with news, with Facebook and stuff, and them being able to pay for advertising, this becomes really important. I just don't think we're talking about it enough.
No, it's a really big problem. And then even AOC, when she spoke to Mark Zuckerberg, she mentioned, like, could you make fake adverts about, like, the Green Deal? And, yeah, people can be lied to.
Nuts.
It is really bad. My learning for this episode is continuing on from the popular topic of cloud seeding. After the response we received, lots of questions were asked, and I had a duty to discover more. So I turned to Google and read a few articles, and it turns out cloud seeding actually is quite a useful tool. It's not just to, like, look at clouds, but so countries such as China, or I think the UAE, like countries within that area, use it to actually make it rain. And a lot of people are thinking about this and saying, should we be playing God and actually making it rain, or should we just let Earth do that? And actually, The Guardian published an article about whether, like, on your wedding day, you could pay money for it to snow or rain. That'd be a bit weird if you wanted it to rain on your wedding day. But yeah, cloud seeding is still a thing. Keep questioning everything. And that's all on cloud seeding for now.
Do you know what? Thank you for your public service announcement. No, but in all seriousness, I was telling you that I read the Extinction Rebellion book, This Is Not a Drill, and they literally talk about cloud seeding. I couldn't believe it, about how they're using it as a tool to combat, like, climate change, to block the sun in certain areas.
Wow.
So it is a legitimate thing. Your Uber driver...
Thank you. I don't remember his name, but thank you, Uber driver.
Thank you, Uber driver. We need to find you and tip you at least $10.
Yeah.
For this service.
Changing people's lives. So, talking about clouds, what is our episode about, Anisah?
Brilliant segue, Serena. This episode is on cloud computing. And excitingly, for this episode, we have 2 guests. We have Dr. Ian McDonald, the Chief Technology Officer in Residence at Microsoft for Startups, or CTO. He's been a great friend to 23 Code Street over the years and is a huge advocate for diversity and inclusion in the tech and startup world. He really does walk the walk when it comes to this, providing support, giving people platforms and championing others, especially people like us.
Our second guest and Ian's colleague at Microsoft is Simona Cotin. She is a global startup advocacy lead at Microsoft. She loves teaching web development and cloud computing.
We're so excited to have you both with us. Thank you so much for being here. So our whole goal for this episode is to demystify cloud computing. So just to kick us off, I'd love to hear what both of your roles entail and why you're interested in this topic.
All right, so my name is Simona, and I work as a startup advocacy lead, just like you mentioned a second ago. And our team's goal is to empower every innovator in the entire world. And we do that through online technical content and supporting them at different communities that they're part of.
Yes, and I'm Ian, and as the title said, I'm CTO in residence. What that means is that I'm old enough to have made plenty of mistakes in my past with startups and businesses. So I'm there to help educate people and tell them how not to make the mistakes I've made in the past, so hopefully the startups run in a much better way.
And what exactly is cloud computing?
It's computers in the cloud. I would say that cloud computing is basically two parts. The first part is the actual infrastructure and the compute power and computers that are sitting somewhere in a data center. And then we have the second part, which is the software that brings them all together and offers us as developers the opportunity to write code more easily.
It's to me, the cloud is really about taking away a lot of the hassles of running your own environment. It's meaning that you don't have to go find a data center. You don't have to, patch all the servers in the same way if you choose some of the services that allow you to do it. Because for the cloud, for example, can enable you just to deploy your JavaScript code without having to worry about all the servers underneath. It means you don't have to worry about building your own databases. You can use a pre-packaged database service, for example.
One of my favorite stories is a story that I listened recently on a podcast about Squarespace, where the founder was actually talking about what were some of his struggles of getting started with the first version of Squarespace. And for him to get his website up so that anyone else could use it, he had to buy 2 different servers. And those servers together were costing $30,000 back in early 2000. So what the cloud enables us to do is no longer have that upfront cost, where in order for our applications to be available for any users that might help them, you don't have to pay anything now, really.
Amazing. And what got you both interested in cloud computing?
Okay, I think I first got excited when Gmail came out, really, and it was sort of taking the whole concept of being able to use email easily, because I've been using the internet since 1988, so I'm a real old timer. And then I could just see how this made it easier. And then spending probably 20 years of racking servers and maintaining servers, it just drove me mad, and being called out in the middle of the night when something went wrong, and had literally one catch on fire once. So it's just doing away with all that made my life so much better, and that's what got me excited.
So my first thought of my attempt at cloud computing was actually me building my own cluster, tiny cluster with 2 different devices for my bachelor thesis. And back then I was building an application that will generate fractals, and it will parallelize mathematical operations. And that was the first time that I had the struggle of having to configure, buy, and manage servers by myself. And then I started using the cloud for side projects. I started using the cloud for building web applications, deploying them to the cloud, and making them available for other people to use them.
So are you both developers then?
I've been both developer and looking after servers, so I've done both in my career. I probably lean more towards the infrastructure side, the actual physical running the machines, but I can certainly do development. And if you download a copy of Linux, you're running some of my code, because I've got thousands of lines of code in Linux.
Amazing.
That's so awesome. And I have a background in computer science. I've written thousands of lines of code, not for Linux, but for applications like banking and insurance companies and data analytics platforms for network data. So it's a mix of both.
So just backing up a little bit, what actually is a server?
a server is, you could consider it like your laptop. Your laptop is sitting there on your desk, but it's a more robust version that keeps running, and it's usually quite big in comparison. And in the old days, you had what were called racks, which were sitting in your office somewhere and had lots of air conditioning. And now those same sort of things are now running in somebody else's data center, where there's a whole collection of these servers. So you could consider it a glorified version of your phone or your laptop. It's just a bigger, more robust computer.
And so where do these servers then sit then? Because we say they're in the cloud. What does that actually mean?
They actually sit in data centers that are being built by some of the cloud computing platforms or providers.
And a data center is like a big, massive warehouse in effect, but it's got lots of cooling, lots of electricity. And so they've got all these servers all stacked up and connected together in massive internet pipes. So they've got, terabits or gigabits of connectivity. So it's really a collection of them all in one place. So, you could think about your big self-storage warehouses. It's like those on steroids.
So I watch Mr. Robot, and obviously that's based on real life. But there are scenes in Mr. Robot where he breaks into a data center and then plugs something in and then writes some code and then steals all his data, and no one knows he's doing it. So are data centers really heavily guarded? Is this a real thing? Are people actually concerned about this?
Yeah, they are very heavily guarded, extremely heavily guarded, and access is very restricted. I know at Amazon, for example, the person who's overall in charge of the whole Amazon Web Services, he isn't allowed in a data center because he's actually got no legitimate need to do it. So it is very much restricted on exactly who needs to do it. You can't have random execs just wandering in because they don't actually need to be in there. So it is very heavily protected.
But also, if we think about security in terms of cloud computing, many times some of the best engineers and some of the best researchers are actually working for some of these cloud providers. And what that means is that some of the solutions that we have in place, what that means is that you have the best teams that are working to make that security very, very good at a data center level, but also at a platform level. And one of the recent or more recent examples that we had from last year with Spectre and Meltdown, where basically the hardware was susceptible to vulnerabilities, the cloud providers had access to those security vulnerabilities and information early on, which meant that they were able to fix that issue for a lot of the people that were hosting their software on that infrastructure. Some of the people that have their own infrastructure, they didn't have access to that info early on, and it took a much longer time to fix those issues. Did that make any sense?
Yeah.
Yeah.
Good, yeah.
Mm-hmm.
I'm learning so much. So much. Given that data centers hold data on all of us and some of the most powerful people in the world, there's obviously a lot of talk around them being vulnerable to attacks in a much more global scale, them being assets in the same way all reserves are right now. What are your thoughts on that, and is that a legitimate concern?
It is partially a legitimate concern. There's lots of things to be done that have been done to protect people in this regards. Remember that the internet was invented about 50 years ago to be able to survive a nuclear attack, and it is a decentralized system at the base to transfer data around. However, having said that, you've still got to design things properly, and cloud providers enable you to say how much you want the data to be spread around. So you can say that I want it to be available globally with multiple copies, or just regionally, or just in one particular server in effect. And this is really enabling people to protect their data, protect at that level. So even if you bombed a particular data center, there is all these other ones around which still have your data on. So you're protected in that regards. And there, you touched on another side about important people, for example, and this is where there's base level encryption on everything in the cloud. So you can choose also whether you want to have your own keys, your own way of protecting the data in the cloud. And this means that even if the government said to Microsoft, give us your data. We could give it to them, but they couldn't make any sense out of it because it's totally encrypted and we as a provider can't even access it. So there's certainly a lot of things like that.
I'm imagining that there's just going to be more and more data centers. So how will this affect our planet? Is it a negative effect having more data centers, or is it not too bad?
For sure, we've got to think about the impact on the environment, and we certainly do that in the whole industry is. So there's a number of ways that we're dealing with that. There is drawing on green energy like wind. Nuclear is actually fairly green because it's not emitting carbon. It's looking at all those sources that aren't producing carbon for power. It's getting the efficiency there, because efficiency in the cloud now is much more efficient than running your own data center, because people, they don't make it as efficient as they could be. And remember, most of the time this is just shifting it from one place to another, and the big companies are actually really good at getting this right. And so I think all of the cloud providers have now committed to be totally carbon neutral and are largely carbon neutral now. And yes, it is getting bigger and bigger, but there's also more and more efficiency. It's the classic thing with computing is you can do more for the same amount of power and the same amount of cost as time goes on. I was at a company where I replaced about £5 million of equipment with a bill that came to only $20,000 per month, US dollars, because we only needed it for peaks, and so it was hugely inefficient. And doing that does make it far better environmentally. But what everybody is doing is moving to carbon-free power, so it won't just be carbon neutral, but will not be using any carbon at all, not even offsets. And that's why a lot of the data centres being built are in areas with hydropower or strong wind, up towards the Arctic Circle, for example, where you don't need to cool so much. There's also projects going on, like some data centres now are having the heat extracted and being used to heat local homes, for example. So you're saving energy in that way.
Cool. So just talking about what Microsoft does, your cloud computing provider is Azure, right? Are you the only people on the market, and what else is out there?
Yeah, so we're definitely not the only people on the market. You also have Amazon with AWS. You have Google with Google Cloud Platform, and
there's people like Netlify. There's people like DigitalOcean. They're a little bit more niche, and they're more sort of for getting started as opposed to working at a large enterprise. So there's a range of people there, and you can consider things like Salesforce as cloud provider as well, because they're providing an application running in the cloud. There's a whole range of software vendors as well. I think choosing a cloud provider comes down to what meets your needs. You look at how things are easy to use, how they do things like AI, how they do things like data storage. So really it's about looking at those added value services in my mind, because to be honest, Google, Amazon and Microsoft share the same base characteristics, but then each of us is differentiated in other ways.
And there's also the question of whether you would only need to host your website, or you foresee a future where you might want to add AI, you might want to add some other types of services that will help you grow your application. So if you're looking to experiment with a single part of the cloud, then probably using a dedicated cloud that does that one thing very well, it's your best bet. Otherwise, if you're looking to explore more services and more complex capabilities for your application, then working with clouds like Azure is one of the best choices.
And sometimes it comes down to things like location or government regulations. For example, Azure is in over what we call regions or places, in over 50 places now, which is more than the opposition, and we've got the most compliance to government regulations. So, for example, if the Swiss government says you have to be in Switzerland, then we're a logical choice. And there's a whole lot of things that can come into play there, for example.
And another aspect of that is also latency. So if you think, for example, you're developing applications in South Africa, then Microsoft has the only data center in Africa. So considering the fact that your customers are in South Africa, you're building your application there, then it makes a lot more sense to host it there. So that can be an aspect of choosing your cloud provider.
And I think that's a good aspect about the cloud as well, that's empowered people all around the world. Simona was recently in Africa teaching development skills there, for example, and that really wouldn't have been possible without the cloud. So it's really democratized and made it available, both easily available and more affordably available as well.
Where in Africa were you teaching?
Yeah, I was in Lagos, Nigeria, and in Nairobi, Kenya.
Oh, nice. Amazing.
What I've noticed while being in Lagos in Nigeria was this incredible energy, and almost everyone around me was an entrepreneur. The fact that they were able to publish their applications and build products that would help their peers, their communities, but also expose them at a global level without having to pay that upfront cost, that made a huge change. And you'll see that everything, like the industry there, is just booming.
And that's probably a good plug that for many startups, the cloud providers will give you free credits as well. Microsoft would obviously love you to do that, but so do the other cloud providers. So if you want to get started, in many cases you can do the getting to know it without paying a single cent or penny.
And that's really good to know as well, right? And how would people find that if they wanted to find those free credits?
For us, just search on the web for Microsoft Azure free.
Nice. Easy Google.
So if you wanted to work in cloud computing, what technical skills do you need?
You can get started on the cloud pretty easily, actually. There's a whole lot of training websites around. There's people that are well-known like Pluralsight who are doing training. There's, of course, 23 Code Street where can help you out. We've got online something called microsoft.com/learn. You can go there and you can actually use the cloud for real and learn about it, but you don't have to pay because it runs in something called a sandbox, which is the cloud but just made available to you for free for learning purposes.
One of the things to keep in mind when you're getting started with the cloud is that you can use exactly the same technologies that you would be using in your own environment in the cloud as well. Most of the cloud platforms will have support for any programming language. So, for example, some of my programming languages are JavaScript and Java. I will find that on Azure as well. They also have support for any operating system that you might be used to, so you can use Linux or Windows in the cloud. And most of the times you'll also have support in your IDE, so in your editor for code. You will have support for integrations with the cloud as well. So in our case, we have a very good integration between Visual Studio Code and Azure. There's different extensions there that will allow you to deploy your applications using VS Code. They will allow you to inspect your data that you store in your database directly in your code editor. And then it will also allow you to run machine learning with Jupyter notebooks and VS Code as well.
So we have an episode coming up on open source, but as you are Microsoft and you own GitHub, I thought it would be cool to ask a question around how open source is powering junior developers and how you think they can use the cloud to get better.
Open source is having the code for your program freely available and freely modifiable without restrictions on it. So it's giving you the power to understand what you're doing with your computer. So we totally believe in open source. We're the biggest contributor to open source in the world. So we're trying to make it really easy for everybody. So you can take the open source software and build it for free on Azure, for example. And as a fun fact, more than half the computers that people spin up on Azure are Linux and not Windows. Of course, it's great for Windows, but if you want to get started and use open source, then Azure is a great place to do it, as are other cloud providers too, I must say.
And fun fact, one of the products that we have on Azure, which is called Azure Functions, the runtime for that is actually open source. So if you go on GitHub and you want to inspect the code that is running in the cloud platform, or you want to contribute to that, or even if you want to run it in your own machine, you can do that very easily. So good aspect of that is that if you're actually interested in learning how you can run your own cloud platform, you can do that through the open source projects that are available on GitHub.
So when I think of cloud computing as someone who's non-technical, I instantly think of Google Drive and iCloud. Is this the same as the cloud computing you're talking about, or is it different?
Absolutely the same. It's represented just in a different way. It's a consumer-facing service, where what we've been talking a lot about is more business-facing. But yeah, iCloud, Google Photos, even Spotify you could consider a cloud provider, because they're streaming data out of the cloud.
So essentially, is what we're saying is that the cloud hosts all the data that you couldn't then host yourself?
Correct.
Good.
I remember the days when I had to basically share music. We shouldn't make this public. So we had a shared drive, a shared folder in our network with in my neighborhood, and then we would be sharing music and films, and I guess that was the first version of the cloud, maybe.
So a lot of people in my family, when I speak to people and say just upload your stuff to the cloud, they're just like, no, like it will disappear. I don't trust it. Like one day I'll open it and it'll all be gone. Could this actually happen? Like, could all your stuff just go?
In theory, yes, but in practical terms, no, because there's so many copies made out of it. And to be honest, how many times have you lost photos when you've, taken your phone for a swim by accident, or your computer hard drive's broken, or whatever? So the chances are that it's going to be much, much safer in the cloud.
What are some of the fun projects you're seeing, Simona, that are coming out maybe as side projects or as fun things that big companies are doing?
One of the interesting projects that I've seen recently being deployed using cloud, but also with very, very practical aspects, was this programmer. He built IoT device. He used Azure IoT, which is Internet of Things, and he used that in order to power a fan. So whenever the room temperature goes above 22 degrees, he would start that fan. And the reason why this project was even more impactful was because the person that built it is based in Lagos, Nigeria, and they have this, first of all, they have the problem of power outages. So his fan was working offline as well. And then it's always hot. So he was basically solving two different problems using the cloud and using IoT devices.
Talking of fun, the whole gaming world is powered by the cloud these days. Whether it's Twitch or Mixer, they're powered by the cloud. You're starting to see things like xCloud coming out now that we're now got available for testing, which is enabling you to run Xbox games on your Android or iOS phone. So, in effect, you don't have to have that big console sitting in the sitting room anymore. If you're at your friend's place or your grandma's place or whatever, and you want to have a fix of Fortnite, you can pull out your phone and start playing, and it's run remotely in the cloud.
I love that you got Fortnite in there. Brilliant. All right, we're going to play a game.
Let's do it.
So, as you may or may not know from our first episode, we have a little game that we like to play with you. And the game is to give us the full forms of the acronyms or short forms of as many of the following as possible. We know you don't actually need to know this in real life, but we like to test you. So, the score to beat is 10, which Jenny Brennan got on the What is Code episode. And Serena is going to time us for 30 seconds and count your score. Are you going to play together?
Yes.
Are you
Doubles
ready?
our chances.
Or halves them. All right. And you kind of count us down?
Okay, 3, 2, 1, go.
SAS.
Software as a service.
CAMP. CAMP. You can say pass.
Pass.
CDN.
Content delivery network.
FTP.
File transfer protocol.
HPC.
High performance computing.
HTTP.
Hypertext transfer text protocol.
Hypertext transfer protocol.
S3.
Storage.
Simple storage. Something like that.
IP.
Internet protocol.
EC2.
And elastic computing.
That's
What are the
1,
ups and the
2,
lows?
3, 4, 5, 6, 7, 8, 9.
You've loaded us with 2 Amazon questions in there, EC2 and E3.
I mean, we kept it around the topic, which,
Yes.
do you want to know what the other ones were?
Yeah.
DAS.
Don't discuss it. I don't
Data
have
transfer, data
I don't know.
as a
Don't know.
service.
Desktop as a service.
Oh, yes, that's that's new. Yep,
Yeah,
you're right.
there was loads. There was like DAS, PAS.
Yeah, platform as a service.
Yeah, and bunch of those. RRS,
RRS. Regionally redundant storage.
reduced redundancy
Oh,
storage.
reduced redundancy storage, I'm guessing. On that. Yeah.
Very good. VPC.
Virtual platforms.
I don't know what it
Secured.
stands. Virtual platform computing, virtual private computing, I don't know.
Virtual private cloud.
Cloud.
And then the one that I really enjoyed was IG, because I would have obviously said Instagram.
Yeah, I was
No, I don't know that one either.
Internet gateway.
So we have learnt tons about cloud computing. Thank you so much for joining us. We really loved having you on episode 2.
It was awesome. Thank you for having us.
It was a lot of fun, even if we didn't win the competition.
I love it. Thank you both so much.
Thank you.
Thank you so much for listening to this episode on cloud computing. We'd love you to get involved in the conversation, and you can find us on Instagram and on Twitter at 23 Code Street. Thank you so much to Serena Chana for being an excellent co-host. Thank you to Tom Salmon for our brilliant jingle. Thank you to Sarah Almond for being the best editor ever. And thank you to the pod at White City Place. We look forward to you tuning in for episode 3, which will be coming out really soon.